Okay, so I've been thinking about some topics that we cover more times than not at the Algebra 2 level, certainly the pre-calculus, and it's a topic that's proves troublesome for students, at least the students I've worked with, which suggests to me that we should talk about it sooner than Algebra 2 and pre-cal so that enough time is given to thinking about the calculations as to move the needle forward in one's ability to work with mathematics. And so that's what this video is about. So it's a rather unconventional approach, I think. And so I don't know if the language will be appropriate as we move through the topics here that I'd like to discuss, but let's have at it. All right, so I'm going to pose a question, and then you pause the video at different times that I pose questions and think about the question and see where your thought process takes you. So right now in Algebra 1, we've been defining some trig functions, having some good success with it. Sine, cosine, tangent. We've done a lot of Pythagorean relationships, and we're moving along nicely. So now I'm going to ask you if you can graph the tangent function. And we haven't done any unit circle work yet with radian measurements, and we haven't put it all together. And yet I don't think we have to. I don't think it's necessary. So I'm going to go close one of the curtains because see, we've got some reflections here that we might want to deal with. So while I do that, you think about graphing one period of the tangent function. And I will be back momentarily. Let's see. Let's see if this, yeah, that helps a little bit. All right. And you know, it'd be nice if you could also, while you graph things, let's see if I can see this. Yeah, name the axes appropriately. There, I think I've got, yeah, got everything in view. So give some names to your axes, and that's another question. So pause the video and give your X and Y axis some names. And I'm just going to keep talking, assuming that you've actually pushed the space bar. Well, I doubt that it has connected yet, but we've been talking about it. I keep mentioning something, I think, over time, not as much in this class yet as in, you know, if it was a trig class, but there's only one thing you do in trigonometry. Well, actually, two things you do in trigonometry. And what are they? Okay, does that prompt bring back any recollection? Probably not at this stage. I don't think you've heard it enough, but I'm going to say it again. I give you an angle, you give me a ratio. I give you an angle, you give me a ratio. Well, there's the answer to the x-axis. It's angles. Let's see. We'll do angles in blue. Okay. Angle. Ratio. And I think I'm going to change the name ratio to fraction. Okay, so I give you an angle, you give me a fraction. Okay. We don't have any defined angles to ratios other than, you know, some Pythagorean relationship ones, but we haven't done things like the sine of pi over 6 or the sine of 2 pi over 3, things like that. We're gonna. I think it's important that we get that far this year because I've been asking students in my calculus classes what the sine of pi over 6 is and the sine of 2 pi over 3, and I'm not getting responses. So I think we want to start that discussion now too. But we don't need that in order to graph the tangent function. All right, and I guess that brings us to a major topic of number sense. You know, I guess we have to get a feeling for fractions. All right, so pause the video again, tell me what you know about fractions and what those values can be. Okay, so tell me all you know about fractions. You're describing numbers now. You're describing a fraction. Yes, and what can a fraction be? Well, when we describe numbers, we generally describe them in terms of they can be positive, they can be negative, or they can be zero. Or there's one more category. Pause the video and tell me what it is. They can be undefined. Okay, so when is a fraction positive? It's bigger than zero. All right, a fraction has a numerator and a denominator. And so when is that bigger than zero? Well, now we're talking about signs. When they're either both positive, numerator, denominator, both positive, or they're both negative. And when's a fraction going to be negative? Well, when one's positive, one's negative, or one's positive, one's negative in that situation. And so, and we're going to be drawing what? What's trig about? TRI. What's it about? It's about triangles. So I guess if you're going to graph the tangent function, you're going to have to draw some triangles. And we're going to put them in a circle here, because eventually we're going to be working with something called the unit circle. And I've only graphed half of it right now, the right half of the circle. All right, and we're going to attach, we talked about attaching, our triangles to the origin. We've already done that. And so let's just draw a triangle. There, I drew a triangle. We've already defined tangent, height over width. All right, so we're back to how do you evaluate a trig function? You can pause the video and see if you can answer the question. I give you an angle. You give me a ratio. Okay, I've given you an angle. Here's an angle. So now it's all just about number sense. It's approximating. What do you think that angle is? Well, we're going from 0 to 90. 45, be right in the middle. All right, I'm going to call that a 20-degree angle. Okay, ballpark figure, just 20 degrees. So over here we got, we'll call that 20 degrees. All right, just ballpark. All right, what's the ratio? I guess we'll go to some color coding. Let's put our numerators in red. Let's put our denominators in green. The question is, how many times does this red amount? How many times does this green amount, I should be saying, which is, I don't know, that size? How many times does that fit into that? Well, certainly less than 1, but they're both positive. I would say that's maybe 1 to 3. 3 of these? Yeah, I think that's pretty close. So I would say a third. So let's get our blue marker out again. And let's call that 1/3. Left-handed. Wow. Pretty good. Boom. We have one coordinate plotted. And if we want to get a picture here, I think we got to do a lot more. So let's do an OOP triangle. Let's see if we can nail something. Why don't we do that angle? Okay, I want it blue. It's going to be fun. I'm going to mix up the colors completely all the time, but I hope you get the idea. All right, so what do we have? We have a new angle. There we go. Now I got my blue one back. All right, let's make the hypotenuse blue. All right, because we're going to draw a triangle straight down 90 degrees, right? That's what we've been practicing. We got red into green. Well, that was my best attempt to get a what? A 1-to-1 ratio. So if that's 1/3, then 1 is maybe here. And it looks like 20 degrees has turned into, you can always pause the videos, right? That's my best guess for where 45 degrees is. And so it looks something like that. Okay. And I guess I just got to keep drawing triangles. Let's get one that's really close to a 0 degree angle, really close to a 0 degree angle. Okay. And so there's my red divided by my green. Red divided by green. Doesn't seem like the lower I get, the smaller this red gets. I mean, I could make it really small, really, really small. And how many times would green fit into red? I don't think much at all. Seems like it's getting smaller and smaller and smaller. In fact, I think when it closes on top of itself, we have a fraction where there's no red. There is no red height. And how many times is this green length fit into that zero? I guess it doesn't at all. Nice, so we'll get my blue marker. There we go. Doesn't fit at all. You know, it looks like this thing is going up. I guess the question is, how much does it go up? Well, that means my angles are getting what? Bigger. So I guess we gotta draw one that's kind of big. Got my blue. Got my numerator in red. Got my denominator in green. And it looks like we've got ourselves a reversal here, where we're getting small widths going into bigger and bigger heights. Bigger and bigger heights. Do that. And how many times is that going to fit into that? Probably lots. Probably lots. You know, it just looks like it's, you know, as that width gets smaller and smaller and smaller and smaller. I think it's fitting into this more and more and more times. In fact, I think it might even go to an infinite number of times. Until we get to what? The magic moment where the width gets to be, you guessed it, 0. And that happens when I'm at what angle? I hope you say 90 degrees, which is twice that. Okay, so looks to me like we got an undefined moment here. Got an undefined moment at 90 degrees where there's no width to the triangles. Of course, I've been very discriminatory here. Seems to me I've only been dealing with the positive width and positive numerator, x's and y's. And the width I should give a green. And the heights I should give a red. Not used to doing this color coding, and I should make that a, yeah, you can tell it's morning. Okay, and that seems like a kind of a coordinate system. And as I think about it, fractions can be big, fractions can be small, fractions can be undefined. But we also said that fractions can be negative, and I guess that means I got to draw my triangles here. So let's see. Okay, and that looks pretty much familiar to a green, a red, small red divided by a big green, a big, where am I? Yeah, big green, right, long green, but green. Big green, right? Big green, but my reds are now what? Negative. Reds are negative. Those fun. Red. Oh, well, you know what? Instead of getting 1/3 this time, I think I'm getting negative 1/3. Blue. There we go. There's negative 1/3 right there. Negative 1/3. Yeah, that's a fraction, all right. We're describing it with adjectives. Positive, negative, big, small, 0, undefined. And I think you can see where we're going. We're going to go to 45 here. Negative 45, sorry. So this is negative 45 degrees to that one, right? Going down 45. So over here, we want to go down 45, which is maybe here. I don't know. All right. And it sure looks like we have a what? -1 to 1 ratio. -10 to 10. Doesn't matter the size, right? We're getting the same ratio. So it's -1. That's a key moment here. So it's a key moment here. All right. And I hope you can see that cutting to the chase. we've got ourselves something that looks like that until what? Until we come all the way down here. What happens as I keep moving this angle towards negative 90 degrees? Well, what's happening is the widths are getting smaller until they get what? Really, really tiny. And when they're really, really tiny, right here, then I'm drawing triangles that have significant height in the negative direction, but the widths are really, really small. And how many times is that going to fit into that? Lots of negative times. So we're headed towards negative infinity. So we got ourselves another asymptotic behavior. All right, at negative 90 degrees, we got ourselves another situation undefined, right? Because we have a 0 into something close to -1, and if we were in a unit circle, and we got ourselves one period of the tangent function. And then, of course, if we, started drawing it, past 90 degrees, we have a width that's negative and a height that's positive. I've lost my color coordinating. All right, and what we would have is something that's going up there, and we have, I'm running out of space here, and it's an Algebra 1 class. But what are we really covering? What's a fraction? Positive, negative, big, small, equals 0, undefined. We want to have that discussion because that's elementary school mathematics. Right, so, and it leads into some stuff that we're going to be talking about exclusively, intensively, all the time. Who knows what words to use? Rational functions. When you start graphing things like what does y over x minus 5 over x plus 2 equal? Still just a fraction, right? Number sense. Fundamentals of trig. What do we talk about? I give you what? You give me what? Not rocket science. I give you an angle, you give me a ratio. Or if I give you a ratio, you give me an angle. Okay, so what do we have? We've been working with the sine. What have we been plugging in there? Angles, right? We haven't been naming them yet, but we've been drawing them, just like we did here. And what have we been getting over here? Ratios, and we're doing pretty darn well with it. Well, I think everybody's, I give you a drawing in standard position. I give you x equals 5. I don't give you the y value, but I'm giving you 7 for the hypotenuse. So everybody's giving me, angle A here. We've just been calling it angle A. And people have been doing those in their head. 49 minus 25, 24, square root of 24. And what's the sign of angle A? Square root of 24 over 7. We've just spent a couple of days on it, and everybody's doing that quickly and easily. So we're off and running. We got something in front of us. We got a what? We got a function that works on an angle and gives us a ratio. And we could do the inverse of it and talk about it right now because we've established that what the inverse notation is. All right, so in this case, the inverse notation is the sine inverse of, and if you type this into Google, sine inverse of the ratio, 24 over 7, you can find out what the angle is. Right, so we want to talk about those things before you get to those higher levels and work with more difficult material, because we got to get the fundamentals understood, all right, in order to then use them to solve problems. And I don't think, based on my 45 years of teaching math, that students are given enough time to actually process topics that they need to process at a fundamental level, and then do more difficult problems. So we're going to look at the fundamental levels at our fundamental entry into the discussion of what you study at the high school level, so that we can build off. Okay, and we only have a little bit more to build with respect to dealing with some triangles that we don't need a calculator for, so that we can talk the language of trigonometry. And so we want to get there. Okay, building blocks. All right, one on top of another. Foundation. If you don't have those building blocks at the lower level, foundation crumbles. And that's why we're probably, as a nation, 36th in the world in mathematics. So let's change it. All right. Have a good time, folks.